We're doing some triangle stuff. We've been doing trig the past couple of weeks. We will just pick it up right there. Some of this may be familiar, some of it maybe you've forgotten, but it's all good. So, sine law. You can use SOHCAHTOA if you have a right-angled triangle, but you're not always going to get a right-angled triangle. In that case, you have to use either the sine law or the cosine law. What is happening in this question? So there's a trunk of a tree. Don't know if we did this. I think we did this one.
We did.
Let's go this here. So they've given us a diagram. They've given us two different angles, and we are to find the height h. All right. So I'm just gonna label these. We can call this A, we can call this B. If you look at triangle AQP, this one right here, we know this is 32 degrees, and we know this side length from P to Q is 105. And we know this is A. So here we have two different triangles. We have this one on the right, this one, and then we have this one in the middle. Actually, there's three triangles. Like you have this smaller one here, and then you have this one here, and then you have the bigger picture triangle. So there's three triangles in there in total. The goal is always going to be to look for the side that both of them have in common. That's always going to be the plan. So between the triangle on the left, APB, and the triangle on the right, AQP, which side length do both of them have in common? You can draw it out here, but they have one side length in common, and that's the one that we're going to attack. So we have this H, and then we have APB, and this angle is 40 degrees. So if you look at these two triangles, they have one side in common. Which side is it? It's going to be this one right here. Right? This one, AP. You see AP and AP? They both have this side in common. So that's the side that we're going to look after. Let's look at the triangle on the right, APQ. We know this is 40. Do we know what this angle is? What is angle APQ? So this one right here,
140.
140. So this angle here is going to be 140. Can we find AP using this information? We have one angle, two angles, and one side length.
We can.
Okay, so to use sine law, what you do is you take an angle and you need its opposite side length. Here we have a side length of 105, but we don't have that opposite angle up here. What is this angle going to be? We know the two other sides of that triangle. One of them is 140, one of them is 32. It is going to be 8, right? Because it needs to add up to, yeah, it needs to add up to 180, so it's going to be an 8. Now let's set this up. Look at this. The way this works is you take, what are we looking for? We're looking for a side length. So you use this formula here. AP, we don't know what that is. That's what we're looking for. AP divided by the opposite angle, sine of the opposite angle. So AP is here. The opposite angle will be 32. So AP divided by sine 32. We have one unknown. We can't have any unknowns in this equation. What is that going to be equals to? It's going to be something over sine of something. It's going to be a side length divided by the angle that's opposite to the side length.
105/8.
Yeah, 105 over sine of 8, like that. And that's going to give us AP. So this one, make sure I am in degrees. So 105 times sine 32 divided by sine 8. So that gives me AP is 400. All right, so now that we know AP is 400, the side length right here is 400. Look at this triangle now, ABP. That is 400. This is a right angled triangle because this is vertical to the ground. How do you find H? It's a right angled triangle. We know one of the angles and we know the hypotenuse of that triangle. Is it a SOHCAHTOA question?
It is.
It is, right? So we are looking for the opposite side, H, and we have the hypotenuse. Which trig ratio uses opposite and hypotenuse?
Sine.
Sine. So it's going to be sine of 40 is equals to the opposite side, which is H, divided by the hypotenuse of that triangle, which is 400. So therefore H is just simply 400 times sine of 40. So 400 times sine of 40, that gives me an H value of 257.1 meters. And you are done. Cool?
Mm-hmm.
So again, the trick here is you need to attack the side length that both triangles have in common. Even if there's 3 triangles, you just attack what they all have in common. 3 is going to be a little bit trickier though. For 3, what you need to do is you need to attack this, and then using that, you need to attack this. We'll see 3 in a little bit. So here they've given us angles. Those are called angles of depression. It's always from the horizontal. So here we have, I'm going to call that, well, C, I guess. We have this triangle, A, B, C. In that triangle, it's not a right angle triangle, that's for sure. We know that this side length is 9750. If this is 32, what part of this triangle is 32? With which other angle here is 32? And this has to do with the Z rule. If these two lines are parallel, this angle and this angle will be the same, or the opposite Z
B
rule.
is 32.
Yeah, B is 32, like that. So that's our first triangle. You can call this D, I guess. And our second triangle is BCD. Like that. So does that make sense actually? Let's just stay with this one, because we don't really need D. The question is asking us for AB, the side length of AB. Okay, you see this?
Mm-hmm.
That's gonna be the width of the lake. Okay, here's a random fact about a lake. So this is a lake, okay? You have, this has to do with chemistry, so it's not random. You have a can of pop, I don't know, you have a Coke or something. It's warm, okay? You want to chill this. How deep should you put this can? What would be the best method for you to cool that can? You're gonna put it in the water. Now the question is, how deep should you put it? What do you think? What does intuition tell you?
As deep as you can,
Okay, why is that?
because the temperature gets colder.
That's right, actually, because actually it's gonna depend on what the season is. In, I don't know where you're canoeing in the winter, but if you're canoeing in the winter versus canoeing in the summer, it depends on the season. If it's the summer, you would definitely want to put it as deep as you can, because when is water the densest? Water is dense at a certain temperature. It has the highest density. It's at 4 degrees Celsius. So what happens in the summer is that up top, the water is very hot. It's like 25, it's very warm. And as you go down, the temperature decreases. And then you're eventually gonna hit this barrier. There's a name for this. I don't know if it's not that important, but this is called a thermocline. Beyond this, the water temperature is going to be 4 degrees because dense means it's heavy. The heaviest water comes at the very bottom, okay? So in the summer months, you want to maybe tie this to a string or a rope and throw it as deep as you can so that you penetrate this thermocline and you get 4 degrees. In the winter, it's opposite. In the winter, temperature up here is going to be the coldest. So you have like 1 degrees, 2 degrees. And as you go down, the temperature is the warmest, 4 degrees. Okay? That's how fish survive the winter. They just swim very deep. So that's the difference there. Anyways, for this question, going back to this question, um, if this is 45, if this is 32, what is this angle? So the big angle is 45, the small angle is 32,
It's 13.
it's 13. So we know that this angle in here is 13. We are interested in this, okay, AB. How do we set this up using the sine law? It's going to be something over something equals something over something. Here, let me set this up. It's going to be, we're looking for AB, right? It's going to be AB over sine of something. Sine of what?
13.
13. That is going to be equals to something over something. Both of these cannot be unknowns. We know both of them. So what do you put on the right side? It's in that triangle there, the numbers that we haven't used.
I can't read the number.
It's 9750, this one, divided by the opposites,
32.
32, there you go. So just multiply both sides by sine 13 and you're done. That's it, okay?
Mm-hmm.
All of these are very similar. If you see the side length, you're good. So there's a balloon somewhere, and there are two angles of depressions. So the closest part of whatever this is, we can call that A. So it's looking at the closest part and then it's looking at the furthest part. And the question is to find the distance from the width of this A to C. And we know that 54 and 71. So this big angle must be 71 and this small angle must be 54. And we know that from the balloon, the closest part is 270 meters away. The question is, what is this side length? Okay, what do you think? What's going to be our approach here? It's very similar to the last question.
First, you can do 71 minus 54.
Yeah, so that will give us, what, 17?
Mm-hmm.
Okay, and then? Do we know any other angles in this triangle?
C is 54.
Yeah, and that's it. You basically have the answer now. So set this up. It's going to be something over something equals something over something. It's going to be AC over what? Sine of what?
17.
Okay, equals to the two sides that we do know. Well, we only know 270. 270 divided by what?
54.
Yeah, sine of 54. And then you multiply both sides by sine 17 and you're done. That's it. Okay? Not that difficult. Let's move on to cosine. This one looks a little bit long, but we can start with this one. Okay. Now the sine law you would use if you had a pair. By a pair, I mean you have this angle and then you have the opposite side length. If you have a pair, you want to use the sine law. For cosine law, you want to use this if you don't have a pair. So what does that even mean? It means something like this. You have this side length, you have this angle, and you have this side length. Notice you don't have any pairs, right? The angle is trapped between two side lengths. In that case, you want to use cosine law. Cool? This means, what does this mean? This means you have your side, you have the angle in the middle, and then you have another side. This is called SAS. That's one reason to use the cosine law. Another one is if you have all three sides. This is called SSS. You don't have any angles, but you have all three sides. That is also a cosine law problem. So that's the difference. Sine law you want to use
Mm-hmm.
when you have a pair. Cosine law you want to use when you don't have a pair. Or if you have all three sides, that's also a cosine law problem. So over here in this triangle, we don't have any angles. So that's how we know this is a cosine law problem. So first, let's use algebra to isolate for cosine A. So we have a squared equals, I'm just rewriting the same thing, but the goal here is to isolate for cosine A. I want cosine A on one side of the equation and everything else on the other side. So this is just pure algebra. What do we do to isolate for cosine A? You wanna get rid of everything else that's not cosine. Here, I'll give you the first step. You subtract b squared, and then you also
Mm-hmm.
subtract c squared. Okay, now what? What do you need to do on both sides so that you have cosine A on the right?
You divide by negative 2bc.
That's right, you divide by negative 2bc. So that's going to be equals to cosine A. Now you just plug in the numbers. All the letters are given there. A is 55. B is 26, so 26 squared. C is 32. All over negative 2 times B is 26. C is 32. Like that. And you just plug it in, do cos inverse, and then you have the answer. 55 minus 26. From the diagram, are we expecting an acute angle or an obtuse angle? For A. The less than 90 or more than 90?
More than 90.
Yeah, so we're expecting an obtuse angle. I got A as 125 degrees. So does that make sense?
Mm-hmm.
Yeah. So that's a cosine law problem. When you have all three sides, or when you don't have a pair, you're going to use cosine law. Let's try this one. What are we looking for? I think we're looking for side A. Let me just read the question. Okay, we're looking for this angle here. Okay, cool. We're looking for this angle, okay? This angle right here.
Mm-hmm.
Notice we have side, angle, side. We don't have the opposite side lengths or the angles for any of them. We have no pairs. Yeah, you need at least one known pair. We have none of them. All the pairs are unknown. This is gonna be a cosine law problem. Cool?
Mhm.
So let's find B first. We have the angle here. We have two side lengths. We should be able to find this pair by using the cosine law. So all you have to do here is to just plug and chug. So B squared is equals to A squared, which is 8, plus C squared, which is 5.1, minus 2 times 8 times 5.1 times cosine of 60. Plug this in, take the square root, and that should give you the side length of B. So I need to square root this. I get 7, so B is 7. The goal here is to find theta. What do we do now? How should we go about finding theta? Is it a sine law or a cosine law now?
Sine law.
Right, because we know, right? We have a pair now, that's why it's gonna be a sine law problem. So why don't you set this up? Something over something. Okay, here, I'll help you. It's gonna be sine theta divided by something is equals to sine of something divided by something. And these, we know both of them. Sine
Sine
theta,
theta over 5.1.
yeah, is equals to,
Sine 60 over 7.
yeah, that's it. And then you multiply both sides by 5.1, and then you do inverse, sine inverse, and that'll give you theta. Whenever the angle is missing, you need to do sine, cosine, or whatever inverse. So sine 60 times 5.1 divided by 7, sine inverse of this gives me 39 degrees. And that's the question. Done. That's it. Just gonna do one of these just so you get a hang of what the formula looks like. So there's three formulas, but they're all the same. Only the placement of the letter is different. It depends on what you're trying to find. So in this triangle, we are trying to find the side length C, which is from A to B. So do we use, which one of these three do we use? The first one, second one, or the third one?
The third one.
The third one, right? And it's literally just a plug and chug. So C is gonna be the square root of A squared. By the way, A, the small letter A, is the side that's opposite to the angle. This is angle A right here. This would be A. This is B right here, the angle B. 4 is going to be the side length B. So C is going to be the square root of A squared, so that's going to be 7 squared plus 4 squared minus 2 times 4 times 7 times cosine of 62. That's it. And you just plug this in a calculator and you're done. So 7 squared plus 4 squared minus 2 times 4 times 7 times cosine 62. And that is going to be 6.22. And you are done. That makes sense?
Mm-hmm.
The next question, the angle is going to be missing. They've also changed the lettering, but none of that is going to make any difference. So theta is missing, yeah. The opposite side length is 4, okay? The opposite
Mm-hmm.
side length is 4. So the way this works is if you use an angle on this side of the equation, it's going to be the side length that's opposite to that angle. So if you wanted to set this up, this would look something like this. Theta is missing. We know that's going to be somewhere on the right side, but on the left side, the side that's opposite to that angle is going to be there. 4 squared. And then the two sides that are not opposite is going to come next. So there'll be 6 squared plus 7 squared. And again, I'm just following the formula. This A doesn't come back. The side length A does not come back into this side of the equation. 4, 1 and done. It's going to be 2 times 6 times 7 times cosine of theta, like that. See if that made sense. The side length for all three of them, the ABCs, it's just redundant, but the side length comes only once in the equation when you're trying to find the angle. So here, how do we solve this for theta? What do we do? This is our unknown, right? Theta is our unknown right here. We need to isolate for theta, which means you need to take everything else that is not part of this side of the equation to the other side.
You subtract 6 squared and 7 squared.
Yeah, and then after you subtract, what do you do? That gives me negative 69 is equals to negative 2 times 6 times 7 times cosine theta. We're trying to solve for theta.
You divide by negative 2 times 6 times 7.
Right. So that gives me 23 over 28 is equals to cosine theta. What now? The goal is to find theta. We have cosine theta right now. When the angle is missing, what do you do?
The inverse.
Yeah, you're going to do inverse. So theta is going to be the cos inverse of 23 divided by 28. Cos inverse of 23 divided by 28 gives me 35 degrees, and which makes sense, right? If you look at this diagram, there's no way that is obtuse angle. And we are done with this. Actually, I'm gonna save that formula because we're gonna need it for almost every question. Okay, let's try doing this one. Okay, we know everything here. We know this is 2 centimeters. This side, we know all 3 sides, but we don't know any angles. Do we use a cosine law or sine law if you know all 3 sides? All 3 sides means you don't have any pairs. So is it a cosine law or a sine law?
Cosine.
Cosine law. Now look at the way how to set this up. I'm gonna say this, I'm just gonna use the top formula. I'm gonna say this is angle A, which automatically means this is side length A. And B and C, you can give this to anyone. This could be C, that could be B, it doesn't matter. What matters is A and small letter A. The angle and the opposite side length have to be paired up. I'm just gonna use the top formula there. So we have our A, so that's gonna be 2 squared is equals to B is 8, C is 6.5, minus 2. Again, this is never gonna come back. That A only comes up once. 2 times 8 times 6.5 times cosine of theta. And that's the setup here. How do we solve this for theta? It's pretty much the exact same thing as we did in the last question.
You subtract 8 squared and then 6.5 squared.
So it's gonna be 2 squared minus 8 squared minus 6.5 squared. Then you divide it by the leftovers, negative 2 times 8 times 6.5. You do cos inverse and one and done. Let's look at this next one. What's gonna be different here, if anything? What do we know? There's a lot of words here. So he hits a tree, not a tree, sorry, a tee shot from tee towards a hole. Okay. It says H is 270. So we know this distance up here is 270. And this distance down here is 160. The question is, what is this distance? Do we have any pairs on that triangle?
We don't.
We don't have any known pairs. So is it a sine law or a cosine law?
Cosine.
Cosine law is right. What I'm going to say is, again, I'm going to use the top formula. Side lengths are always small case. I'm going to say this is A, and I'm going to say this angle is capital A. I'm going to say this side length is B, well, because it's opposite to B, and we can say this 160 is C. So A is missing, right? We're going to use the top formula. And it's just a matter of plug and chug. Here, look at this. A is going to be the square root of B squared, so that's 270 squared, plus C squared, 160 squared, minus 2 times 270 times 160 times cosine of 23. You plug that in a calculator and you're done. That's it. That make sense?
Mm-hmm.
Just designate your A, B's, and C's and use your formulas. That's all there is to these problems. I'm gonna do one. Is this one? No. Okay. This next one's gonna have 2 triangles, but we know how to approach 2 triangles. What you're gonna do is you're gonna attack the side length that they both have in common. What are we missing? Determine AB, so this is our unknown right here. Let's look at the triangle on the right, triangle ADC. What do we know about this triangle? We know this is 30. Do we know any other angles?
T is 135.
That's right. Look at what it says about D. D is the midpoint of BC. D is the midpoint of BC. So what's the side length from D to C?
It's 1.
It's 1. We're gonna attack AD because AD is a side length that both triangles have in common. What's this angle going to be? We know it's 135 and 30. The other two triangles in, the other two angles in that triangle. What's the upper angle?
It's 15.
It's 15. So now the goal for us is to find AD. Is this a sine law or is this a cosine law? If we're trying to find AD.
Sine.
Sine law, right? So let's set it up. It's gonna be AD divided by sine of what?
30.
That's going to be equals to what over what?
1 over sine of 15.
Right, 1 over sine of 15. So you multiply both sides by sine 30, and you will get AD. So that's just sine 30 divided by sine 15, which is 1.93. Okay, now that we know AD, let's look at this other triangle, which is ADB. So ADB, and this side length is 1.93. This angle is 45. Do we know the distance from B to D?
It's 1.
It's 1, right? And we're trying to find AB. So is this a sine law or a cosine law?
Cosine.
It's going to be a cosine, that's right. Because you don't have any pairs, any known pairs. So what you do is, again, I'm going to use the top formula. I'm going to say this is A. I'm going to say this is angle A. This is B, and this is side length C. So I'm just using the top formula. A is going to be the square root of B squared, so 1.93 squared plus C squared minus 2 times 1.93 times 1 times cosine of what? What's the angle that's opposite to side length A? This is A. The side length, what's the angle that's opposite to this? Do we have that?
45.
45. And then you just want to plug this in a calculator and you're done. That's it. Let's look at this next one, forest fire. What are your thoughts on forest fires? Is it only negative or does it have some positive effects as well? You may talk about it in biology. I don't know if you will talk about it in grade 10 biology, but does forest fire have any redeeming qualities?
If they're natural.
Yeah. So actually what we've started doing is, even if they're not natural, what we do these days, we do this in Canada as well. It's called something called a controlled burn, which is artificial fires that we create ourselves. And it is actually required. Fires are required to reset the ecosystem of like parks and things like that, forests. What usually happens is, again, there's a lot of variables into this, but you want parks or nature in general to be something called homogeneous. It means you want to have small trees, you want to have plants, you want to have big trees, pine trees, deciduous trees, all that sort. That's called homogeneous. But if one of the species is dominating, okay, then what ends up happening is you end up getting a heterogeneous forest, which is something like everything dominated by pine trees. And this happens over
Aren't the
time.
words switched?
I think you are correct. This is hetero. Yeah, you're right. Yeah. This is homogeneous, where everything is like the same species.
Mm-hmm.
So what forest fire does is it kind of undoes this situation and it resets back to this. So yeah, even if it's unnatural, even if it's controlled, it's better for the ecosystem in the long term. So it does have some redeeming qualities. Obviously, the smog and the carbon emissions is another topic altogether, but so that's what we do these days. Anyways, let's look at this question. So there are two towers. One of them is A, one of them is B, and they are 20.3 kilometers away. So from tower A, the bearing to tower B is 70 degrees. So that's obviously not a right diagram, not even close. So A is here, B is here. So, you know what a bearing is?
No.
It's like this. It's the angle from here to like here. If you use a protector,
Mm-hmm.
it's from the vertical. So this angle here is going to be 70 degrees. What else do we know? We know that the ranger in each tower observes a fire and radios the bearing of the fire from the tower. The bearing from tower A is 25 and from tower B it's 345. So there is a fire somewhere here. Let's say this is C, the fire. The angle this way is going to be 25 degrees. And from B, again, it's from the vertical, this angle to C is going to be 345 degrees. And the question is, what is this distance? So it's a little bit complicated, this one, but it's not too bad. It's like a big angle, small angle kind of a thing. We know the distance from A to B is 20.3 kilometers. Think about this. If the big angle is 70, if the small angle is 25, what's the angle in here? You have a big angle, 70 degrees. You have a small angle, 25 degrees. What's the angle between them?
45.
45. So this angle here is going to be 45. And the other one is slightly more complicated. You have something like this here. This angle is 345. The question is, what is this angle? This is 345. This is going to be 15, right, over here?
Mm-hmm.
Because 360 is a loop. What about down here? If that is 15, we're in quadrant 2. This angle is going to be 75, this big angle, okay?
Mm-hmm.
What do you think this small angle is? I'll tell you that it's symmetrical. If that angle up there is 15, this angle down here is going to be 15. This angle in there is going to be 60. So all in all, our triangle, it's a lot of work, but our triangle, this angle is 60. This angle is 45. This side length is 20.3. A, B, C. The question is, what's this side length and what's this side length? This is a cosine law problem or a sine law problem?
Cosine.
Cosine law. So that is A, then that means this is going to be small a, this is going to be small b, this is going to be small c. Let's first find a. I'm going to use the top formula to find a. A is going to be the square root of, actually this is not a cosine law problem because we do have a pair. Yeah, this is not going to be a cosine law problem. Do you see it? We have a pair. If that's 45, this is 60. What's this angle?
Um, it's 75.
It's 75. So is this a cosine law problem or a sine law problem? Now that we know we have a pair,
Sine.
that's sine law. So to find a, you do a over sine 45 is equals to 20.3 over sine 75. That'll give you a. What about b? To find b, what do we do?
Um, B over sine of 60.
Yeah, is equals to what? It's going to be equals to something over something.
Does it matter what pair you choose?
You should probably choose a pair that you do know. So here we only know one pair.
20.3 over sine of 75.
Yeah, and you're done. Just plug and chug. Let's do this one, Leaning Tower of Pisa. I don't know if that diagram is going to help us, but let's pull it up anyways. So we have something to look at. All right. So this is a tower. Okay, that's very steep. That would fall down in like a day. So this is a tower. It is 5.5 degrees from the vertical. So this angle is 5.5. And we know the side length of this tower is 55.9 meters. If its shadow is 90 meters long, so let's say the sun is this way. What if the sun was on the other side? Could the sun be on the other side? I mean, yeah, right? Depends on time of the day. So either we can go this way, it's casting a shadow, or it could be casting a shadow this way. I'm gonna stick with this for now. What is the distance from the top of the tower to the edge of the shadow? So let's say this is A, B, C. We know the shadow is 90 meters. The question is, what is this side length? Okay, what's our approach? Do we know any angles inside the triangle itself? What is this angle here?
Could you subtract like 5.5 from 90?
Yeah, because you're in quadrant 1, it's going to be 84.5. So do we have any pairs? Do we sine law or cosine law here?
Cosine?
Yeah, you want to use cosine law. So again, a is missing, right? We've done this a few times. A is going to be the square root of b squared. What's b? B is 55.9. B squared plus c squared minus 2 times b times c times cosine of the angle that it's opposite to. Like that. And that will give you a, let's see what that gives us. Square root of 55.9 squared plus 90 squared minus 2 times 55.9 times 90 times cosine of 84.5. That gives me 101 meters, 0.29 meters. That makes sense?
Uh-huh.
What we're going to do is we're going to shift the sun to the other side, and let's see if that makes a difference. And I think it will, because now if the sun is that way, then it's going to cast a shadow in the opposite direction. It is going to cast a shadow now in this direction. It's a terrible straight line. Let's call this B, and we know the shadow is still 90 meters. Now the question is, what is this side length? ABC. So what is this? Do we know this angle? Because you'd need an angle. If you think about a quadrant, if you know this angle is 5.5, what is this angle?
95.5?
Yeah, so this big angle here is going to be 95.5. I'm going to do the same thing I did last time. Well, this is small a, this is B, this is C. So the only thing that changed actually is what? If you look at this equation that I have, what's the only thing that changed? It's that angle, right? Before it was 84.5, but now it's 95.5. Let's put that in here and see if that makes any difference. Cos of 95.5. I think it will, because cosine is negative in quadrant 2, so it should give us a higher, I'm assuming it's going to give us a higher value. Yeah, so this way I got A to be 110.4 meters. So it actually depends where the sun is, right? Or what time of the day it is for this question.
So how would you know like what to answer?
If you want to get an A plus, you do both. But I think,
Okay.
yeah, I would do both because it's just, you're just changing one letter here. That's the only thing you're changing. Or you could ask your teacher, be like, hey, what time it is? Mm, T's for thinking. It says two roads intersect at an angle of 15. So let's say that's road A, it's road B, and they intersect at C at an angle of 15 degrees. Daryl is standing on one of the roads 270 meters from the intersection. So let's say Daryl is here, but he could also be there. That's the issue with questions like these. It's ambiguous. He could be at either location. So let's say he's here, right there, 270 meters. Create a question that requires sine law to solve it. All right, we have one angle. We have one side length. If you want to use the sine law, how would you fill up this triangle. What else do you need if you want to use the sine law? And the goal is to find all three sides and all three angles.
You need at least one pair.
You need at least one pair. So what would you give in this question? You can fill any of these blanks. If you want to use a sine law, which one of these would you give? Well, I mean, we have AC, so that's, yeah, you have 4 options.
You could do angle B
Yeah,
and AB.
yeah, exactly. You could do either angle B would work, or you could do AB. That would also work. On the other hand, if you want to use the cosine law, now what can you give?
Angle A.
So you need SAS for cosine law. Angle A would not help you, I don't think, because it only uses one angle. Cosine law only uses one angle, so it's not going to be angle A. You can give side CB, okay? Because then you would have
Mm-hmm.
a side angle side, or you could give all 3 side lengths and you don't even need that angle. But I think to make it easier, you would give CB and you can find AB using that. All right, let's call it a day. I'll pick it up
Okay,
tomorrow.
thank you.
See ya.